Hi everyone, this is Caitlin, and I wanted to do my video on chapter 6 about the sampling and probability and kind of how that played out for me and my assignment 2. So to get started, we talked about non-probability sampling. Something that I really noticed with this is it's not something that I see a whole lot of. And to go off of the definition a little bit, it says samples are based on judgment by the researcher. To me, that means that you're really not being non-biased in a sense of how you're taking your samples and you're making assumptions off of the probability that really isn't that accurate. We see a lot of just regular probability, or samples are generated randomly selecting the sampling units. So I see a lot more of like random sampling than non-probability, just from being around. Kind of how that plays out for our assignment 2. In the first sample, it's non-probability sampling, and so we take the first 10 students and take the average of that. This is particularly biased just because you're taking the 10 lowest scores, and so it's not representative of the population. Now, it could be a little bit better by taking maybe the middle 10 students, like say 45 to 55, say, because that's closer to the middle of the sample that you have, but it's still not representative of the average of the population. That being said, this is a very particular special case of SAT scores that we have the whole population that we're trying to sample. It's a lot easier to do to have the whole population when it's like SAT, ACT, grades, GPA of a college or even a college class. Those populations are a lot easier to find than, say, the whole population of the United States. So we know what our average is, and we know that by taking the lower percentage of the students that this obviously is not representative of the population. Now, moving into our sample 2, it only has a sample size of 10, which isn't very big. It isn't horrible because the sample size is only 100, but still it's not representative of the population. Your average is still not that close to the population average. When you move higher into the sample 3, which is 50, you're taking half of the population. So that's definitely closer than a tenth of the population versus half of the population. So that's kind of important to recognize, is that taking half of your population is going to get you significantly closer to the average than a tenth. Now, in sample 4, we did the systematic random sampling, where you take every nth sample, or every nth student. So in this situation, we did every 10 starting with 5. So it was 5, 10, 15, 20, 25, 30, or 5, 15, 25, 35, 45. Sorry about that. So that's a little bit more representative because you have increments all the way up to the top, and you're not including the bottom 5 or the top 5, so it's not skewed in either direction. Now, if you say didn't put them in order like our population was, then it wouldn't be very representative, because there's a good chance that you could still get the lower percentage or a higher percentage of what the population is. This really only works if you have everything in order from lowest to highest or highest to lowest. Now, for sample 5, what it did was it grouped the population into different groups of 10. So the lower 10, then the next 10, and then the next 10. And then we took one person from each grouping. I feel like this is better and less biased because you have the groups that are similar with each other, and you're taking at least one from each similar sample, right? So I think this also works really well in real life situations because you're grouping people for similarities. So you're making sure that you have someone who is representative of each subpopulation in your population now, or your population average. Something that I found interesting for me was that my sample 3, 4, and 5 actually equaled the same, which I know that's not supposed to happen, but I would, based off of what I saw and just kind of the conclusions I drew from it, it definitely went from least likely to work to most likely to work, or at least like the least likely you want to use. Like, you don't want to use non-probability sampling, but stratified random sampling is probably your best option, especially in this case scenario. Some other things that I noticed were just kind of how it all played out. You know, it's interesting to see how each sample equaled something. I thought it was very interesting that I got the same, and they were all really, really close to the population average. So showing that those three really do work fairly well. So having a larger sample size, and then the systematic and the stratified random sampling. Now, something else that I kind of wanted to go over was population census and sample. So to me, when I think of something like this, I like to put it in kind of like a context. And so I always think of Utah State students, you know, like we are the population of Utah State. And when they send out like those large mass surveys, they're trying to get a census of like every member in the school. And then sample is like when they take a part of it, like maybe even the College Bag or the College of Humanities, and narrowed in on that. Something that I think would be interesting just to like recognize for this is how we could use stratified random sampling for Utah State. So like we have different majors and different colleges within our college, and so taking samples of a student from say every college, like College of Education, College Bag, CHAS, trying to think of everything else, but just taking like one person representative of each college, or even taking one person representative of each major within the college. If you just wanted to look at the College of Ag, that's where I am, so that's the most I can think of. You know, we have ASTE, ADVS, and a couple of other ones that you could pull from and take a stratified random sample of. I think that would be kind of interesting to see how that all played out in like a college setting of students in each college within the college, or each major within the college. But all in all, that's really all of the notes that I have written down. I actually really enjoyed the assignment too, because it showed your probability and how it can, sometimes you can just get really close to the population multiple times, even though that's not necessarily how it always works out. But I hope you guys all got a chance to listen to this video and enjoyed it. And good luck with your assignments and moving forward. And have a great day. I will talk to you all soon. Bye.